like to do today is to start looking at the equation of some of these lines that we have been talking about. All right? And let's look at a number of examples, and I think from these it will generate what we mean. And here's a problem in which we have find an equation of the line with slope 2/3 and passing through the point Q with coordinates of 3, 4. Now let's make a little picture for ourselves, if I may. And let's see now, 3, 2, 3, 1, 2, 3, 4. Let's say that associated with this point is the coordinates of 3, 4. And notice now with a slope of 2/3, it's easy for us to start from this point, and let's run 3 units to the right, and then we may rise 2 units, and then we have this second point, and through those 2 points, then let's say is the line that we have in mind, okay? Now let's take any other point on that line, and let's call the coordinates x, y. And knowing what we do thus far, we have then y minus 4 divided by x minus 3 must be equal to what number? Is equal to 2/3. Does everyone agree that we have here the slope, which is the change of the y coordinates divided by the change of the x coordinates, and that then must be equal to 2/3. Okay? Now let's then look at that and simply multiply both sides through in our equation by the number x minus 3. And right here we see a pattern which is going to turn out to be quite important. In fact, let's actually continue this a little farther. Y minus 4 then is equal to, and using our distributive property, we have here what? There's 2/3 x minus 2. And then if we were to add the number 4 to both sides, 2/3 x, what then do we have? Y then is equal to 2/3 x plus 2 is another pattern which is going to turn out to be quite important for us. And in fact, if we then were to multiply both sides through by the number 3, we have what? 3y then is equal to, anyone? We have here what? 2x plus 6, and then getting it into our general form, our ABC form, we may then write this as negative 2x plus 3y is equal to 6. And we have one pattern here, which is one that we are certainly familiar with thus far. And as this lesson develops, we're going to also concentrate on this pattern, and in fact, this pattern right here. So let's now look at a second example, which is actually a generalization of this first one, in which it says, find an equation of the line with slope m and passing through the point Q with coordinates x sub 1, y sub 1. So again, let's make a coordinate system. And let me pick out any point, or let's say that we have a point Q with coordinates of x sub 1, y sub 1. Through that point, let's draw some line, and associated with that line, let me just indicate some slope number of m, okay? Now, let's take another point on this line, any other point, and again, let's call it P with coordinates of x, y. All right, now what then may we say? But that the change in the y coordinates, let me write it then as y minus y sub 1, all right, over, what then would you like to say? Divided by Dick?
X minus x sub 1.
X minus x sub 1 is then going to be equal to m, the slope number, okay? Now, let's look at this, and just as we did in our numerical example, let's multiply both sides through by what number, Brenda? X minus x sub 1, and we have then y minus y sub 1 is equal to m times x minus x sub 1. And this pattern right here turns out to be quite an important one, and because we have a point, namely the point Q with coordinates of x sub 1, y sub 1, and then one slope number, the slope number m, we give this equation a special name, and it is called the point slope form. The point slope form of the equation of a line, okay? And now here then is our second pattern that we are particularly interested in. So if we know the coordinates of one point, and if we know the slope number, then indeed that gives us a unique line, and we may find the equation of that line by means of this point slope form. All right? Let's then look at a third example. Here we have a case in which it says, find an equation of the line with y-intercept of 3 and the slope number of negative 1/2. And in fact, if we were to make a picture, I think you would agree that what we have is simply a special case of the general example that we just discussed in example 2. For example, the y-intercept of 3 is then going to be this point right here. Let's call it Q with coordinates of what? What are the coordinates of the point Q, Don?
0, 3.
0, 3. And now we have a slope number of negative a half. Let me decide to come out here to the right 1, 2, 3, 4. And from this point, then, what am I going to do in order to come up with a slope number of negative a half? Are we going to rise some number of units, or are we going to fall some number of units? And Peter?
You will fall.
We'll fall how many units in order to come up with a slope number of negative a half? We would like, if I come out here 4 units, we would like to come down 2 units. Is that right? 1, 2. So then here we have this point must be on our line, and through those 2 points then we have this line. Again, now with this slope number, let me just indicate the slope number of negative 1/2 right here. Let's rely directly on the formula that we just developed, namely y minus y sub 1 is equal to m times x minus x sub 1, and we see a special case here. Because what then is, well, y minus, what then is the coordinate of y sub 1? In our picture here it is the number 3 is equal to m, which is what number? Negative 1/2 times x minus x sub 1, which is what number? 0. Well, let's just indicate it here. We then have y minus 3 is negative 1/2 of x, and then simply adding the number 3 to both sides, we have negative 1/2 x plus 3. And this pattern is going to turn out to be quite important for us. Of course, we can multiply both sides through by the number 2 and get it into our ABC pattern, or in our general form. And let's do that. We have there 2y then is equal to what? The opposite of x plus what number? Plus 6. And then we may write this as x plus 2y then is equal to 6. It's in our general form. Well, this pattern that we have right here of y is equal to negative 1/2 x plus 3 turns out to be quite important, because notice that this number, negative 1/2, is what number? That's the slope of our given line. And in fact, the number 3 is also what point are we passing through there?
The y-intercept.
That's indeed our y-intercept. That's where the graph crosses the y-axis. So this pattern is going to turn out to be quite important. And in fact, let's see if we can generalize that. And looking here at example 4, it says find an equation of the line with y-intercept of b and a slope of m. So let's make another picture and try to generalize this, in which, let me pick out any old point, say right here, call it Q with coordinates of 0, b, and through that point we have some line with the slope number of m. And using our point slope form, we have what? Y minus y sub 1 is equal to m times x minus x sub 1. All right. And now here we may substitute a name for y sub 1, which is b. Is that right? Y sub 1 is b, is equal to, our slope number is m times x minus x sub 1 is what number? 0. And again we have y minus b then is equal to m times x, and y then is equal to mx plus b. And this pattern then is the case, the general case of what we're talking about. Notice now, immediately in the pattern that we have here, the slope number is given to us, namely m, and the y-intercept is given to us, namely the number b. Okay? And we give this a special name, and because it does intercept the y-axis, the name that we give it is called, Michael? The y-intercept form. The y-intercept form of the equation of a line. Okay? Now, let's see if we can look at another example. Well, here we have a case in which it says, find an equation of the line passing through the point 2, negative 3, and the point with coordinates of negative 5, 4. And without making a picture, let's go right into our pattern of, let's look at y minus y sub 1 is equal to m times x minus x sub 1. And you say to yourself, well, I have here 1 point certainly. In fact, we're given 2 points, so I have a choice, but I do not know the number m. But in fact, we do know the number m from our definition of slope, which is what? The change of the y-coordinates with respect to the ratio of that change with respect to this change. Is that right? So then, looking at our given numbers here, well, let's say that this is our y sub 2 number,
So we have what? 4 minus, what may we say there? 4 minus a negative 3 divided by negative 5 minus 2. And of course, what then is this number? This is 7 divided by negative 7, which is negative 1. So there then is a slope number of negative 1. Now here we have a choice. We may select either point, and it really doesn't matter. Normally you look for the easier of the two. Oh, let's decide to take this point as our y sub x sub 1 comma y sub 1 point. So here we have what? Y minus, what then may we say? Negative 3 is equal to m, which is what number? Negative 1 times x minus 2. And let's see then what we have. This is y plus 3 then is equal to the opposite of x. And what may we say here? Plus 2. And here then we have y then is equal to the opposite of x minus 1. Is that right? And here then we have a slope number of what? Negative 1. And what is the y-intercept number? Also negative 1. So let's make a picture of that from this equation. And notice how easy it is to make that picture. The slope number, or rather the y-intercept number, is at negative 1. And the slope number is also negative 1. So let's decide to run out 2 and fall 2. And through those 2 points then, we have that line. And notice now, a rough check looking at our ordered pair of 2 comma negative 3. 2 comma negative 3, I think you will agree is this point right here. And looking at negative 5 comma 4. 1, 2, 3, 4, 5. Perhaps it's not quite as obvious. 2, 3, 4. And that point is also on our graph. And a relatively quick sketch here will indicate that certainly those 2 points are on this line. Okay? Let's look then at a last example in which it says find an equation of a line that is parallel to the line whose equation is 3x minus 2y equals 6 and passes through this point at negative 2 comma 3. And you say to yourself, well, let's see now. How may I handle this? So let's look at this equation with the pattern of 3x minus 2y is equal to 6. And you say to yourself, if I only knew what number for this equation, right here, Brenda, if we only knew that slope number, all right, and so let's find that slope number. Here we have what? Negative 2y then is equal to, getting it into our y-intercept form, is equal to negative 3x plus 6. Y then is equal to what? 3 halves x minus 3. Does everyone agree that that then is the pattern that we're looking at? Now we're interested in the equation of the line which is parallel to this one and passing through negative 2 comma 3. So let's make a picture here and see what we have in mind. Now if we were to graph this line, all right, the y-intercept is what point? Negative 3. And what's the slope number? 3 halves. So then let's run 2 and rise 3, and I think at this point, and through these 2 points then, we have that line. All right? Now, we want to now select the second line, which is parallel to that line, and passing through negative 2 comma 3. 1, 2, 3. And so that through this point of negative 2 comma 3, we want to draw a line parallel to this given line, and in fact we want now to find the equation of this line. So, what then is our conclusion about these 2 lines? What certainly can we say, Don? They'll have different y-intercepts, certainly. Yes, that's certainly a good clue. And what else may we say here, Bill?
They'll have the same slope.
They'll have the same slope number. And I think that's probably an important idea here in order to be able to then come up with the equation of this line. So what then is the slope of this line here that's given to us? This is 3 halves. Therefore, what's the slope of this line? 3 halves. And I think then we can find its equation because we know 1 point and we know the slope number. All right, so then let's then go to our pattern of y minus y sub 1 is equal to m times x minus x sub 1. And the point that we have is negative 2 comma 3. So it's y minus what number? 3 is equal to the slope, which is 3 halves times x plus 2. Is that right? X minus a negative 2. And looking at this pattern then, we have what? Y minus 3 is equal to using our distributive property, plus what number? Plus 3, and then let's get it into our y-intercept form. There's 3 halves x. What then do we have? Plus 6. And notice here, let's come back and look at this. What is this pattern called? If we gave this one a name, this is called the what? The point-slope form. Is that right? This is our point-slope form. And now this pattern we call the y-intercept form. Okay? The y-intercept pattern. And now we, in fact, may multiply through here by 2. We have 2y, that is equal to 3x plus what number? Plus 12. And now we have negative 3x plus 2y, then is equal to 12. And what pattern do we call this? And that's our general form. So we have these 3 patterns or forms in which we are particularly interested. Notice they're all equivalent to one another. Is that right? They're all equivalent, and they're simply different ways of writing the equation of a line, and we will pick whichever one is convenient for us in any given problem. All right? Well, let me give you your homework assignment. This will be assignment number 30.